Okay, chlorine reacts with sodium and with hydrogen. Compare the structure and bonding in sodium chloride and hydrogen chloride. And it's worth a total of 6 marks. So 1, 2, 3, 4, 5, 6. So we've got to talk about here about two different lots of things. We've got structure and we've got bonding. Okay, so let's talk about the bonding first. So I'm going to talk about 3 things to do with bonding, okay, of these substances. So sodium chloride, well, sodium is a metal. Okay, hydrogen is a non-metal. Okay, chlorine is also non-metal. So sodium chloride sodium chloride bonds by ionic bonding. Hydrogen, and I might describe here, sodium chloride bonds by ionic bonding, hydrogen chloride bonds covalently. Okay, in terms of the bonding, I need to make sure that I can say a bit more about that. So that's a difference. Electrons, just so I know that the examiner knows that I know what ionic bonding means. Electrons are transferred. In ionic, electrons are shared. In covalent. Okay, what else do I know about them? I know that a comparison, actually, sodium chloride and hydrogen chloride, there are strong bonds in both forms. So there are also atoms in it with full shells. So I'm going to say they're both bonds. So both molecules are held together by strong bonds of attraction. Okay, so that's the bonding, and then I'm going to talk about the structure. So what these things look like. So we get, for sodium chloride, for ionic compounds, we get giant structures, giant lattice, whereas hydrogen chloride will be very simple, a very small molecule. So sodium chloride would form a giant lattice, whereas hydrogen chloride would form a simple molecule. Okay, we've got both are held together by forces. For sodium chloride, the forces would be electrostatic, whereas for hydrogen chloride there'd be intermolecular forces. So both, I'm sorry, let me start again actually. So sodium chloride held together by electrostatic forces, hydrogen chloride by intermolecular. What else can we say about the structure? Oh, actually, in terms of the structure here, if we think about so a lot of sodium chloride, they arrange themselves in a regular pattern. So sodium chloride arranged in regular pattern, whereas hydrogen chloride, each one bombs off and does its own thing. Hydrogen chloride in random arrangement. Okay, so what I mean by that, oh sorry, I've just filled up on page. So what I mean by that is, let me just put the hot, there we go, that's all the answer there. So in terms of sodium chloride, you have positive ions, negative ions, positive ions, negative ions, and you'd end up with this giant lattice shape like this, where the positives would be the sodium, the negatives would be the chlorine, and you'd end up with a structure like that. Whereas hydrogen chloride, what you'd end up with there is you'd end up with HCl, hydrogen chloride. Okay, they just do that. They just hydrogen and chlorine. Okay, so they just be like that, and there's no attraction. Each pair have stuck together, and that's it. They don't need to worry about doing anything else. Okay, hope that helps.